Number 8, we've got this region that's formed by y equals square root of x equals 4 and the x-axis. So we can draw that. We don't really need it for the problem we're going to work, but here's what it looks like. Square root of x out here at x equals 4 and the x-axis. So the region is that region there, and that's going to be some sort of solid that I want to find. Ultimately, I want to find the centroid for it. But first of all, we're going to find the moment with respect to y and the moment with respect to x. So let's calculate those. Remember, the moment with respect to y is the integral from 0 to 4 of x times my function. And the moment with respect to x is the integral from 0 to 4 of the function times my function. In other words, it's my function squared. So it's like y times the function. Okay, so they're easy to set up. But we want to interpret what they mean. And so remember, what that means is if I were to put the fulcrum right here at 0, 0, what the moment with respect to y gives me is the tendency of this thing to rotate on the x-axis in the y direction. So that's going to give it the tendency to rotate this way or this way. And obviously with what we're seeing here, this is going to rotate hard to the top, in the positive y direction. If you tried to balance it by putting the fulcrum there in terms of the y coordinate. So this is the tendency to rotate on the x-axis or in the y direction. So whichever way you want to say it, on the x-axis or in the y direction. And then this is just the other one. This one is then the tendency of it to rotate. When I put the fulcrum here and hold the y solid, this would be the tendency of it to rotate on the y-axis. So anyway, you can write that out. Or in the x direction. And we can see again in this problem it's going to rotate hard to the right because that's where all the solid is in this case. Anyway, now we want to set up the integrals needed to find a centroid. Well, all I'm missing is the area formula. And we integrate 0 to 4, square root of x dx to get the area, and therefore then the x coordinate of the centroid is the moment with respect to y over a, which you can write out if you want, or since I've written them all, I'll go with that. And the y coordinate of the centroid is my moment with respect to x over a. And these actually should have a row in them, but I won't worry about that because the row will cancel out because this also has a row in it. Okay, next one says, does this sequence converge or diverge? And if it converges, find the value to which it converges. So don't just give me an answer. Show me what you're doing to work this out. So we know this one's alternating. And we know that what it's asking me to do is take the limit as n goes to infinity of -1 to the n and -1 over n plus 1. Now, when we do these limits, because it's alternating, I know that the only way an alternating series like this that's multiplied by a -1 to the n, the only way it can converge is if it converges to 0. Because alternating means it's going to be bouncing back and forth. So the only way it can converge is if it comes to here. If it goes to any other value, for example, if it's alternating about this value, it won't alternate. What it'll do is it'll alternate close to whatever that is, but then it'll bounce way up here close to that one. So I'm getting all kinds of dots that aren't making much sense. But anyway, so let's say it's getting close to 1 when I'm taking this limit. Well, it's going to get close to 1, but then it's going to get close to -1. Then it's 1 again, and then close to -1. So it's going to get closer and closer to those values. But to be convergent, it has to approach only a single value. So that's what's actually going to happen here. So we'll ignore this and note that when I take this limit, I'm going to get 1 by either L'Hopital's rule, by taking derivative of each, or by rates of growth, which is these two things grow at the same rate. So that limit goes to 1, which says what I was trying to explain here. If this part's going to 1, the alternating part means you're actually bouncing between 1 and -1, getting closer and closer to each one, but that limit does not exist. So it diverges.